Graph theory is a branch of mathematics that deals with the study of graphs and their properties. A graph is a collection of vertices or nodes and edges that connect them. Graphs are used to model real-world situations such as social networks, transportation systems, and communication networks. The history of graph theory can be traced back to the 18th century when the Swiss mathematician Leonhard Euler solved the famous 7 bridges of Nixburg problem. The problem was to find a walk through the city of Nixburg that would cross each of its 7 bridges once and only once. Euler proved that such a walk was impossible, and in doing so, he laid the foundations of graph theory. Graphs can be classified into 2 main categories, directed and undirected graphs. In a directed graph, the edges have a direction, while in an undirected graph, the edges do not have a direction. The vertices or nodes of a graph can be connected by one or more edges. Graphs can also be weighted or unweighted. In a weighted graph, each edge has a weight or cost associated with it, while in an unweighted graph, all edges have the same weight or cost. The degree of a vertex in a graph is the number of edges that are incident to it. In a directed graph, the in-degree of a vertex is the number of edges that point to it, while the out-degree is the number of edges that point away from it. Graph theory has many applications in various fields, such as computer science, physics, chemistry, biology, and social sciences. It is used to model complex systems, analyze networks, and solve optimization problems. In the next segment, we will discuss some of the basic concepts and definitions of graph theory. In this segment, we will discuss some of the basic concepts and definitions of graph theory. A path in a graph is a sequence of vertices that are connected by edges. A simple path is a path that does not repeat any vertices or edges. A cycle is a path that starts and ends at the same vertex and does not repeat any other vertices or edges. A connected graph is a graph in which there is a path between any 2 vertices. A disconnected graph is a graph that is not connected. A component of a graph is a maximal connected subgraph. A tree is a connector graph. A forest is a disjoint union of trees. A bipartite graph is a graph in which the vertices can be partitioned into 2 sets such that there are no edges between vertices in the same set. A complete graph is a graph in which every pair of distinct vertices is connected by an edge. A clique is a subset of vertices in a graph that form a complete subgraph. A matching in a graph is a set of edges that do not share any vertices. A maximum matching is a matching with the largest possible number of edges. A planar graph is a graph that can be drawn on a plane without any edges crossing. A planar embedding of a planar graph is a drawing of the graph on a plane with no edge crossings. These are some of the basic concepts and definitions of graph theory. In the next segment, we will discuss some of the algorithms and applications of graph theory. In this segment, we will discuss some of the algorithms and applications of graph theory. One of the most well-known algorithms in graph theory is Dijkstra's algorithm, which is used to find the shortest path between 2 vertices in a weighted graph. The algorithm works by maintaining a set of vertices whose shortest distance from the source vertex is known, and iteratively adding vertices to this set until the destination vertex is reached. Another important algorithm is the breadth-first search algorithm, which is used to traverse a graph in a breadth-first manner. The algorithm starts at a given vertex and explores all the vertices at a distance of 1 edge from it before moving on to the vertices at a distance of 2 edges, and so on. Graph theory has many applications in computer science, such as in the design and analysis of algorithms, network flow optimization, and database management. For example, graph theory is used in the design of routing algorithms for computer networks and in the analysis of social networks. In physics, graph theory is used to model complex systems, such as the interactions between particles in a material or the behavior of a network of neurons in the brain. In chemistry, graph theory is used to model molecules and their properties. The atoms in a molecule are represented as vertices, and the bonds between them are represented as edges. In biology, graph theory is used to model biological networks such as protein-protein interaction networks and metabolic pathways. In social sciences, graph theory is used to study social networks and their properties, such as the spread of information and the formation of social groups. These are just a few examples of the many applications of graph theory. Graph theory is a powerful tool for modeling and analyzing complex systems, and its applications are widespread and diverse.